Welcome to Algebra 1, Unit 9, Lesson 8-4, More Multiplication Properties of Exponent. Pearson Algebra 1, copyright 2009. I'm Mr. Polarski, and our objectives today are, I will be able to raise a power to a power, and I will be able to raise a product to a power. To fully understand how to raise a power to a power, and then how to raise a product to a power, we're going to have to understand this first property. Raising a power to a power. For every non-zero number a and integers m and n, a to the m raised to the n is equal to a to the mn. That's the really important part of this to understand. And what's happening here is when we raise a power of m to the power of n, to calculate the power or to simplify the expression, we need to multiply those powers. Let's take a look at two examples here. In the first example, we have 5 to the 4th power being raised to the 2nd power. Now we know we have a power to a power because we have this power of 4 separated from the power of 2 by a parenthesis. We can show the work here by writing it as 5 to the 4 times 2 power. And that simplifies to 5 to the 8th power. So when you're raising a power to a power, you have to multiply the exponents to simplify the expression. Moving on to the second example here, we have x to the 2nd power being raised to the 5th power. Again, we know we have a power to a power because of this parenthesis right here. To the 2nd power being raised to the 5th power. We can show the work by writing it as x to the 2 times 5 power, and doing that multiplication, the expression simplifies to x to the 10th power. Example 1, simplifying a power to a power. In this example 1, these are the easiest types of problems you can encounter when it comes to working with a power to a power. Part A, we have a to the 3rd power being raised to the 4th power. As I showed in the first two little examples on the property page, since we have a 3rd power being raised to the 4th power, we can apply that power of a power property directly, which means we'll write as our work a to the 3 times 4 power, and then we simplify what's in the exponent by doing the multiplication. So this is going to become a to the 12th power. Final answer here is a to the 12th. And we arrived at that by multiplying the two exponents, the power to a power. Now in example B, we have x to the negative 6 being raised to the 2nd power. Again, we know it's a power to a power because of these parentheses separating the negative 6 power and the 2 power. We'll worry about that negative exponent in a few minutes. But first we're going to apply the power of a power property, so we can rewrite this as x to the negative 6 times 2. And when I multiply those two powers, that gives us x to the negative 12. Now one problem that I've been finding with my students is that they're leaving negative exponents in their final answer. Well, negative exponents cannot be put in a final answer. And we learned how to correct a negative exponent in lesson 8.1 with the negative exponent property, which says if we have something to a negative power, we can put it under 1 to make it a positive power. So x to the negative 12, when corrected to a positive exponent, will be 1 over x to the positive 12. Here's our final answer. Example 2, simplifying an expression with powers. Now these two problems are a little more complicated than the first example, but they're really not that bad. In part A, we have b to the 2nd power times b to the 3rd being raised to the negative 2. In this case, we have two bases of b, but before we try to put those two bases of b together, we have to do this power of a power first. And we'll apply that property that we just learned. And since we're not doing anything with that b squared, we'll just bring it down for now. And when I rewrite this b to the 3rd to the negative 2 power, we'll rewrite that using the power of a power property, which will tell us to write it as b to the 3 times negative 2. Next, we do this multiplication right here. We do that. We simplify that. Since we're not doing anything with the b squared yet, we bring it down. And b to the 3 times negative 2 power gives us b to the negative 6 power. Now we're going back to continue to simplify this. We're going back to lesson 8.1 and using the product of a powers property where it says if we are same bases, where we're multiplying the same bases. We have b to the second times b to the negative 6, and as we learned in lesson 8.1, we need to rewrite that with one base b, and that would be to the 2 plus negative 6 power. We simplify what's in the exponent. 2 plus negative 6, that'll give us b to the negative 4 power. And like we saw in example 1, we need to correct this negative exponent, b to the negative 4, by writing it as 1 over b to the 4th power. This is our final answer here. Now let's recap this part A. First, we applied the power of a power property to simplify b to the 3rd to the negative 2, which gave us b to the negative 6. Then we used from here to here, we use the multiplying powers with the same base property, which says if you're multiplying two same bases, we add their exponents, which we did. 2 plus negative 6 to give us negative 4. And then we finally use the negative exponent property to rewrite this as 1 over b to the 4th. Moving on to part B of example 2, we have p to the 3rd raised to the 4th times p to the 5th raised to the 2nd. Well, we have two powers of a power problems here. P to the 3rd to the 4th can be and should be rewritten as p to the 3 times 4 power. And p to the 5th raised to the 2nd using the powers of a power property should be rewritten as p to the 5th times 2 power. Now we simplify each one of these exponents. P to the 3 times 4 gives us p to the 12th. P to the 5 times 2 gives us p to the 10. But since we have two bases that are the same and are being multiplied, we have to use multiplying powers with the same base property, which means we add the exponents. So we rewrite this with one base, p, and that'll be 12 plus 10 in the exponent. And finally, we simplify that exponent to get p to the 22 or 22nd power. Final answer here, for example, b is p to the 22nd power. The second property in today's lesson is raising a product to a power. And to be able to raise a product to a power, you have to understand how to do what we just did with a power of a power. For every non-zero number a and b and integer n, the product of a and b to the n is equal to a to the n times b to the n. What this is saying is if we have two things being multiplied and then being raised to a power, we can apply that power, in this case n, to both of the things inside the parentheses. And in other words, we can distribute the power on the outside to everything on the inside. Now we have this example here, the product of 3x to the 4th power. Now you can see by using that distributive property or raising a product to a power, we have to raise 3 to the 4th power, which is here, and we also have to raise x to the 4th power, which is here. Now this isn't our final answer. 3 to the 4th, x to the 4th is not our final answer because 3 to the 4th can be simplified. And 3 to the 4th gives 81 because it's 3 times 3 times 3 times 3. So final answer here is 81x to the 4th. Example 3, simplifying a product raised to a power. Part A, we have the product of 4x to the 3rd being raised to the 2nd. As we just saw with the property, we need to distribute this power of 2 to x to the 3rd and x to the 4th, which means we have to raise x to the 4th to the 2nd power, and I'll write that down as 4 squared. And now we need to raise x to the 3rd to the 2nd power. This is the power of a power property. We're going to write x to the third being raised to the second power as x to the 3 times 2 power. From here we simplify. We actually do 4 squared, which is 16, and then we simplify the exponent on the x, 3 times 2 to give us x to the 6th. So the final answer for part A is 16 x to the 6th power. Example B is a little bit different because it has a negative exponent right here. You can see that negative exponent. It's a negative 3 power. And we're going to deal with that negative first in this example. We're going to use the negative exponent property, which tells us we take whatever's being raised to the negative power and put it under 1. So using the negative exponent property, I'll rewrite this as 1 over the product of 3x to the 5th to the positive 3 power. Now we do what we did in example A. We have to apply this exponent of 3 to x to the 5th and to 3. And to do that, or in other words, another way of saying that is we need to raise 3 to the 3rd power, and we need to raise x to the 5th to the 3rd power, and we use the power of a power rule to do that. So that would be x to the 5 times 3. We simplify the exponents. 3 to the 3rd, well, we're going to put our answer as 1 over, and 3 to the 3rd is 27, because it's 3 times 3 times 3, and x to the 5 times 3 power gives us x to the 15th power. So our final answer here is 1 over 27x to the 15th. Example 4, simplifying a product raised to a power. This by far is going to be the most complicated example of this video lesson. And what we have to do is first raise powers to a power. So we're going to need to take this 2 and apply it to the y to the 3rd and to the x and to the 4. So when I rewrite that first part of this problem, it's going to become 4 to the 3rd, x to the 3rd, and y to the 3 times 2. The last part of it, x to the 3rd to the negative 3rd, I have to raise a power to a power here, which means I need to raise x to the 3rd to the negative 3rd power. I'm going to do that in red. It's all one problem, but I'm going to show you the separate parts here. When I do that, I'll write that down as x to the 3 times negative 3. Notice I didn't fix the negative exponent just yet like I did in one of the previous examples. So now when I start to simplify this, 4 to the 3rd power is 64. 4 times 4 times 4 gives 64. X to the 3rd can't be simplified right now. Y to the 3 times 2 can be simplified to y to the 6th. And x to the 3 times negative 3 power can be simplified to x to the negative 9. Now that we have applied our powers to the power rule, we need to look for like bases, and we do have like bases. The x's are like bases, and when we multiply like bases, we add their exponents. So I'll take another step here. I'm not doing anything with the 64 right now, so I write it down, and since I have x to the 3rd times x to the negative 9, I should rewrite that as x to the 3 plus negative 9. And I copy down the y to the 6th since I haven't done anything with it yet. At this point, I need to simplify the exponent on the x. I'm not doing anything with the 64, so I write it down. Simplifying the exponent on the x by 3 plus negative 9, which gives negative 6. And since I have not done anything with the y, it'll be y to the 6th. Last step is to correct this negative exponent. I don't have a fraction right now, but I'm going to have a fraction as my final answer. The positive exponents will be in the numerator. So in this case, that would be 64 to the 1st, or just 64. And y to the 6th in the numerator, since it's positive. Now to make this x to the negative 6 a positive 6 power, I put it in a denominator. So our final answer here is 64 y to the 6th over x to the sixth. I put a circle around it because it's my final answer. Remember, when you're raising a power to a power or a product to a power, you will be multiplying the exponents. When you raise a power to a power, you multiply exponents. This has been Mr. Pilarski on more multiplication properties with exponents. Thanks for watching. Bye-bye.